Hello, this is Mr. Stansbury. I'm going to take you through the notes on arithmetic sequences. At the end of this, you should be able to say, I can show a sequence is arithmetic, find the formula for the general term, find a given term, and find if a given number is a term given a sequence of numbers. All right? Okay, so first things first. An arithmetic sequence is simply a sequence which each term differs from the previous one by the same fixed number. We call this number the common difference. So like 1, 3, 5, 7, we're adding 2 each time. That's the common difference, D. Okay, an arithmetic sequence can also be called an arithmetic progression. Okay, just a different name for it. Okay, the general term or nth term of an arithmetic sequence is always written in this formula here. Okay, where U sub n, we call it, is that's saying the general term. Okay, where these n's here, both these yellow n's are the term number, and then equals U sub 1, which is the first term, plus, again, the term number, minus 1, all times the common difference. Okay, so this is the formula that we're going to use over and over and over again. Okay, so let's use this formula here to figure out example 2. Okay, so consider the sequence 9, 15, 21, 27. Show that the sequence is arithmetic. Okay, so for A, to show that this is actually an arithmetic sequence, to show that this is an arithmetic sequence, you got to show 3 different times that the difference is the same. Okay, so what we want to do is you always want to go take the term and subtract the term before it, and that will show you the difference. So we're going to do that 1, 2, 3 times. So we do 15 minus 9. We're going to do 21 minus 15, and we're going to do 27 minus 21. And hopefully these are all going to be the same. 15 minus 9 is 6. 21 minus 15 is 6. 27 minus 21 is 6. We have shown that this here is, it's going up by 6 each time. So we have shown that the sequence is arithmetic. Okay, we're now going to find a formula for the general term U sub n. So we're going to find this formula here. So for B, let's just go right over here and use this formula. So we've got U sub n. So this is the general term, is U sub 1, which is the first term, which in this case is 9, plus n, the number of terms, which we don't know, so we'll just leave that as n, minus 1. And then D is the common difference. Now that's what we just figured out. So D equals 6. Okay, so we just figured out that the difference is 6, so 6 is going to go here. And then what we're going to want to do is we're going to want to distribute this 6 back to both of these here and simplify this. So we got U sub n equals 9 plus 6n minus 6. So really U sub n is, we usually write the term with the variable in it first, 6n, and then 9 minus 6 is plus 3. So there's our general term formula. Not this, because this can be simplified. We always want to simplify it so that we get a better formula. Okay? And if you'll notice, our common difference 6 here is not a coincidence that this number here is 6. That means that each term is being multiplied by 6 each time. Okay? For part C, find the 50th term of the sequence. So now that we have this formula, we can actually find any term number that we want. So we would say, officially we would write U sub, the n, if you remember, n is the term in the sequence. So really, this would be U sub 50. And this is really saying the 50th term is going to equal 6 times 50, 50 plus 3. So the 50th term is going to be, 300 plus 3. So the 50th term is 303. Okay? D, is 387 a term of the sequence? So we want to figure out if 387 is actually going to be one of the terms that would fall in this sequence. So let's go through and figure that out. So we basically want to know, is 380, will this will this sequence here ever equal 387? So we'll do 387 equals 6n plus 3. So we're going to just go through and solve this. Subtract 3 from both sides. 384. Sorry, that is terrible handwriting. 384 equals 6n. So we're going to divide both sides by 6 and see what we get for n. Okay? So we've got 384 divided by 6, and we get 64. So since we get a whole number, 64, and not 64.2 or some kind of decimal, since we get a whole number, that means, yes, it is a term in the sequence. In fact, it's the 64th term would be 387. Again, if this was any kind of decimal at all, anything except for a whole number, an integer number, then this answer would be no, it's not part of the sequence. Okay? And then E, what is the smallest term of the sequence that is larger than 1,000? So we're going to kind of use the same idea that we did with D, and we are going to simply plug in 1,000 for our answer here, right, for the u sub n. So when is this sequence going to equal 1,000? So subtract 3 from both sides. 997 equals 6n. So we'll get our calculator back. And let's see, we're going to divide both sides by 6. Got a little ahead of myself, sorry. So we get 997 divided by 6 is going to give us, it's going to be the 166.1 term. So we want to find the smallest term of the sequence that's bigger than 1,000. So if we did the 166th term, it would be just less than 1,000. So we want to actually do the 160, instead of 166, we want to do the 167th term. So we're simply just going to plug 167 into our u sub n formula right here. So u of 167, so we're saying the 167th term is going to be equal to 6 times 167 plus 3. So let's see what that gives us. Okay, so 6 times 167 plus 3 gives us 1,005. So the smallest term in the sequence that's larger than 1,000 is 1,005 for that one there. Okay? Okay, before our next example, let's take a little funny video break. All right. Here we go. Example 3. Find k, given that k, 2k plus 1, and 11 are consecutive terms of an arithmetic sequence. Okay? So, from what we learned before, we know that if it's an arithmetic sequence, the difference between each of these 3 terms should be the same. So what we want to do is we want to take the second term minus the first term, and then the third term subtract the second term. So we've got 2k plus 1 minus k, and then we're also going to take 11 minus 2k plus 1. Now, these differences here should be equal. So this difference here should be the same as this difference here. So what we're going to do instead of this is we're going to actually set these two things equal to each other. So really this means that this is going to equal 11 minus 2k plus 1. Because again, as long as it's an arithmetic sequence, the difference between the first two should equal the difference between the second two. Okay? So let's do that. We'll get rid of this here. And then let's see what we can do about simplifying this and figuring out what k is. Okay, so we got 2k plus 1 minus k. So let's simplify that already. So 2k minus k is k, so we got k plus 1 over here, and then over here we have 11 minus 2k minus 1, right? So we got k plus 1 equals negative 2k, and then 11 minus 1 is plus 10, right? So I'm going to add 2k to both sides, right? And that gives us 3k plus 1 equals 10. Subtract 1 from both sides, and we get 3k equals 9. We divide not by 9, but by 3. Divide both sides by 3, and we get that k equals 3. So this number here, this k here, should be 3. So let's check to see if it works. So we get 3. 2 times 3 is 6, plus 1 is 7, and then 11. 3 plus 4 gives us 7. 7 plus 4 gives us 11. So we know that k equals 3 is correct. Okay? All right, that's all for this half of this arithmetic sequence notes. We'll pick up the second half of this on the second video. Okay?